Hey class, it's Brett Carter, and I'm going to talk to you about AD and LDAP and the best practices and implementation of both. Alright, about AD. AD stands for Active Directory and is Microsoft's trademarked directory service. Active Directory is a special purpose database which is not a registry replacement. The directory is designed to handle a large number of read and search operations and a significantly smaller number of changes and updates. Active Directory is a data hierarchical, replicated, and extensible. Because it is replicated, you do not want to store dynamic data such as corporate stock prices or CPU performance. If your data is machine specific, store the data in the registry. Typical examples of data stored in the directory include printer queue data, user contact data, and network/computer configuration data. The Active Directory database consists of objects and attributes. Objects and attribute definitions are stored in the Active Directory schema. Active Directory has three partitions. These are also known as naming contexts, which are domain, schema, and configuration. The domain partition contains users, groups, contacts, computers, organizational units, and many other object types. Because Active Directory is extensible, you can also add your own classes and /or attributes. The schema partition contains classes and attribute definitions. The configuration partition includes configures data for service, partition, and sites. Alright, best practices and implementation of AD. For one, it is recommended that you do not log onto your computer with administrative credentials. When you are logged on to your computer without administrative credentials, you can use run as accomplish administrative tasks. Rename or disable the administrator account and guest account on each domain to prevent attacks on your domains. Physically secure all domain controllers in a locked room. Manage the security relationship between two forests and simplify security administration and authentication across forests. Restrict user, group, and computer access to shared resources and to filter group policy settings. Establish as a site every geographic area that requires fast access to the latest directory information. Establishing areas that require immediate access to up-to-date Active Directory information as separate sites will provide the resources required to meet your needs. Place at least one domain controller in every site and make at least one domain controller in each site a global catalog. Sites that do not have their own domain controllers and at least one global catalog are dependent on other sites for directory information and are less efficient. And finally, perform regular backups of domain controllers in order to preserve all trust relationships within that domain. About LDAP. LDAP, which stands for Lightweight Directory Access Protocol, is a software protocol for enabling anyone to locate organizations, individuals, and other resources such as files and devices in a network, whether on the public internet or on a corporate intranet. LDAP is a lightweight, which is smaller amount of code, version directory access protocol, which is part of X.500, which is standard for directory services in a network. LDAP is lighter because in its initial version, it did not include security features. LDAP originated at the University of Michigan and has been endorsed by at least 40 companies. Netscape includes it in its latest communicators suite of products. Microsoft includes it as part of what it calls Active Directory in a number of products including Outlook Express. Novell's NetWare directory services interoperates with LDAP, and Cisco also supports it in its networking products. In a network, a directory tells you where in the network something is located. So on the TCP IP networks, which are included in the internet, the domain name system is the directory system used to relate the domain name to a specific network address. However, you may not know the domain name. LDAP allows you to search for an individual without knowing where they're located. An LDAP directory is organized in a simple tree hierarchy consisting of the following. The root directory, this is the starting place or the source of the tree, and then it branches out to countries, each of which branches out to organizations, which branch out to organizational units, and these are divisions, departments, and so forth, which branches out to finally individuals, which include people, files, and shared resources such as printers. An LDAP directory can be distributed among many servers. Each server can have a replicated version of the total directory that is synchronized periodically. An LDAP server is called a directory system agent. An LDAP server that receives a request from a user takes responsibility for the request, passing it to other directory system agents as necessary, but ensuring a single coordinated response for the user. Best practices and implementation for LDAP. Alright, 1. Account management. Where LDAP entries represent accounts used by people or applications, it is important to have effective management processes in place. For personal accounts, this should include automated updates from human resources systems and other databases to provision new accounts and disable old ones promptly. It is normally best to avoid deleting accounts, as that leads to greater risk of reusing identifiers and also some problems in interpreting audit logs. 2. Authentication. LDAP servers generally support 2 different authentication methods, Simple Bind and SASL. Simple Bind is in use, then TLS should also be used to prevent exposure of passwords on the network. As LDAP is often used to validate passwords for other services, this is likely to be a very common situation. Servers should disallow the use of passwords when TLS is not in use. Very few server products have this as their default setting, but it should be seriously considered. 3. Password policy. Most LDAP systems store and validate passwords. Indeed, for many, it is their primary function. Following the X.500 get back exactly what you put in principle, servers normally default to storing passwords in clear text or in a form that can be converted back to clear text. In most cases, this is not necessary. Wherever possible, passwords should be stored using a non-reversible cryptographic hash, including a significant amount of salt. This provides the best possible protection against the recovery of passwords from stolen disks or backup tapes. SSHA-1 is the best commonly implemented hash at present, but server administrators should consider moving to better hashes such as the SSHA-2 series when they become available. Note that passwords protected using AES and other symmetric algorithms are likely to be recoverable from stolen media with very little effort, as the encryption keys are almost certain to be present on the same media. Alright, number 4. Constant service. LDAP is often used by multiple user-facing services, so maintaining availability is extremely important. With careful planning, it should be possible to do complete hardware and software upgrades without any break in service. This can be achieved using replica servers and either client-side fallback or LDAP-aware proxies and load balancers. Client software often deals poorly with server failures. A solution for this problem is to run an LDAP proxy service on each client system so that the client software is always talking to a local service. Okay, 5. Development and test environments. Normal good practice dictates that development and test environments should be completely isolated from the production environment. A more difficult decision is what data to load in those environments. A copy of the production data gives the best emulation of the product environment, but the data is still sensitive and subject to strict legal protection. A representative set of synthetic test data should be generated and used as the normal load on both development and test systems. The data set must be large enough to give realistic results to client queries. Occasionally, it may be necessary to load a copy of the reduction data on the test system, in which case care must be taken to protect it and to erase it completely when it is no longer needed. 6. Human factors. It is generally recognized that the legitimate users of an IT system are the most likely route for a successful attack on the security of that system. This should be countered by training and awareness campaigns, but system design has a part to play too. Any system that makes it too hard for people to do their job will eventually be subverted or bypassed by the users. This suggests that the technical controls should not be set too strictly. Further, there has to be a trade-off between human enforced and machine enforced policies. The LDAP server cannot be aware of the intention behind a particular operation, so it can only enforce very simple rules based on the data that it holds. Business logic and other applications may have a wider view, but ultimately decisions have to be made by people. And finally, monitoring and audit. Most LDAP servers have the ability to log changes in text format. It's very useful to developers and system managers, but the format is not always convenient for audit. Some servers have the ability to maintain a change log or a generic operation log in a database that can be searched using normal LDAP operations. Be aware that there's a cost to all logging, and for searchable logs it can be quite high because each event must be recorded and indexed in a database. This can make full accountability feasible on busy services. This concludes my presentation on AD and LDAP. Thank you for listening.